Okay. So we'll continue from last time here. Just a little short review. POTS stands for plain old telephone service, and a regular telephone set uses just one line, which is one pair. And the old color code is red and green, or green and red for tip and ring, and that corresponds to the blue pair of the first pair of the 25 pair color code, which we're going to tackle today. So blue, orange, green, brown, these are the first pairs of the 25 pair color code. So the red and green, or green and red, corresponds to the stripe and blue, the blue pair. So the stripe conductor of the blue pair would be the tip, and the solid, considered as a solid, even though here this has wider stripes, or this was narrower stripes, it's considered a solid. So the solid would be ring. Right? So just as a reminder, where's ring and tip? Tip is the positive part of the quarter-inch jack that used to be used to patch through the telephone calls before the dial tone was introduced. And the ring, the sleeve would not exist. It was just a ring, one long ring. This is just a balanced signal, so tip, ring, and sleeve. So if it's an unbalanced signal, then it would just a tip and ring. The sleeve doesn't exist. This would not be separated here. It'd just be one continuous connector terminal. All right. So tip is positive with reference to ring, but also tip is neutral with reference to ground. So tip is grounded, and the ring is negative in reference to the tip. Okay, so it's just you gotta kind of look at it a few times and get that thing in you. All right. All right, USOC Universal Service Ordering Code, and remember the pairs. We count the pairs in the USOC configuration. So here's pair 1, and we're just moving outwards. We are moving outwards. Pair 2 is outwards towards pair 1, and then pair 3 outwards more, right? So we just go pair 1, pair 2, pair 3, pair 4. That's the USOC configuration. Please do not confuse that with the T568 color code, which we will cover later on. That applies to the data connections, right? All right, and then jacks. This is an example of a surface mount jack, and over here you have the red and green, black and yellow. See, red and green, black and yellow. Okay, and so on. So this will be the screw terminals. That will be the typical wall mounted jack, wall mount jack, surface mount. Sorry, surface mount. The other one would be wall mount, which would be just one that uses a grommet, rectangular grommet, and single gang faceplate sometimes, yeah. And it's mounted on the wall, and the other ones are modular. The ones that we actually have used in our labs. Wiring pods, pair 1, pair 2, pair 3, pair 4. This is just a text representation of what you see here. So this is just one more way of looking at it. So we're not going to analyze it. We already have that. Okay, now a couple of devices that you can see in real life. All right, and we do have one of those in our lab. So next time you are in our lab, take a look around, see if you can spot this device here. This is the demarcation point terminal. All right, demarcation, or the demarc. Demarcation stands for basically it means the point of entry. Okay, now. This would normally be installed on the outside of the building, so you would see something like that on the outside of the house usually. This demarcation terminal accommodates 2 lines. How is it doing just that? Also, it has a ground protection, so any communication line that goes outside, even for 1 inch, right? It has to be grounded or lightning protected. The lightning protection has to be installed. Now you can see green here and red, so this would be line 1, and if you needed a second line to be activated in your house, you would run the line to here, green and red. All right. Now these two wires, they go inside that RJ12 registered jack 12 terminal, okay, or RJ11, and they're also wired into these screw terminals right here. So you can, and this is just a RJ registered jack configuration here. You can unplug that and disconnect this red and green terminal. So this would be line 1 here, all right? And this would here be another line. They're not even numbered, okay? So because there are 2 lines, I think you can make heads and tails out of this one pretty quickly, all right? Now there is also a ground terminal right here, and this device, that doesn't look like much, but it actually is the lightning protection. If there is lightning hit, this lightning protection is going to take the hit and get it to the ground before it has a chance to travel further down the line and into your house. That is the idea of it, all right? Of course, nothing will give you an absolute guarantee that lightning is not going to get through anything, right? All right. Keep going here. A typical demarcation room that is inside a building. This normally you would see in a commercial environment. So over here, this would be the outside lines. And when you open that, you should not open that if you're a third company, but if you're working for a company that installs that, there's 100 pair telephone cable runs into this junction box, and there are buttons numbered from 1 to 100. And basically, if you want to activate a line, you just push the button in, as simple as that. And this here, there's a 100 pair cable goes, and it's terminated on something that's called a BIX block. So one BIX terminal, all right, accommodates 25 pairs, which we're going to study today. 25 pairs according to the color code of 25 pair color code, right? So look at that, 25, another 25, that's 50, another 25, that's 75, another 25, that's 100 pairs, okay? So 100 pairs, multiply it by 2, you're going to have 200 conductors actually going in that cable here. And a 100 pair cable accommodates 25 pair cables inside that big jacket. And they're just broken out and terminated according to the color code of 25 pair color code. Now from here, on the other side of this terminal, you have something that's called a field wiring. What is a field wiring? Field wiring is the wiring that goes to the individual outlets inside the building. Okay, so that's called field wiring. And sometimes you're going to see a 25 pair cable going there, which means that could go into a secondary demarcation point somewhere else. Let's say, for example, there's a huge department store that requests, let's say, 50 lines or 20 lines or something like that. So they're just going to designate maybe 1 or 2 strips for that department store and just run 1 or 2 of those cables towards that sort of like a secondary demarcation point that serves that department store. This over here would be the main demarcation point that services all the, let's say, stores in a mall. All right. Over here is these are something that's called T1 connections, and we'll talk about those later. We will come back to that slide here. Okay. Now POTS filtering. Right? Plain old telephone service filtering here, okay? Related terminology, DSL, dry loop, or voice, right? Some of us might remember these devices here. That's what happens. Okay, let's see if someone has an existing hardwired telephone line going into the building, and quite often you're going to have a DSL internet. DSL stands for Digital Subscribers Line. Okay, so what is going to happen, that telephone line is going to carry the regular POTS signal, which is going to give you a dial tone when you pick up the phone. But also on top of that, there's going to be a superimposed internet signal. right? Those are basically going to be mixed all together. If you connect just a regular telephone line and you pick up the phone, you're going to hear the dial tone, and you're also going to hear the high frequency buzz that is basically the analog internet connection, right? Internet signal. When that happens, whenever you dial the number, the dialing circuitry is going to recognize you dialing the number, you dialing by tone. However, that internet or the DSL signal is not going to go away. It's going to be there all the time. So when somebody else picks up the phone on the other side, you can have a conversation, but in the background you are going to hear that really annoying DSL signal that is going to just after a while it's just going to drive you crazy. Okay. So what happens is that we need to be able to filter them out. So you could do it in two ways. You can, wherever you are going to have a telephone set, you're just going to plug in that filter, and this jack right here, this plug, is going to plug right into the telephone outlet, and your telephone was going to be plugged into the other side of this device, of this filter. So this filter is going to filter out, make it disappear, the DSL line, and let only the frequencies that have to do with the voice, right? So basically it's like a low-pass filter. All right, so wherever you have a phone, you plug one of those, or you can have a one common POTS filter that you're going to install that right at the demarcation point, and you're going to have the whole line in. So over here you have the modular jacks, right? Or you have the screw terminal. Basically you just use your choice. If you have a jack, you can just plug it in here, or if you don't have a jack, you just have two conductors, just that's it. You can strip them and connect them to the screw terminals. So either or, right? These are the same points. Notice tip and ring here. And the tip and ring, of course, is going to be in the two middle prongs, right? Because that's just the pair number one. So it's always line one or any line. If it's just one line, single existing line, single line, then you're going to connect that to the two middle prongs, okay? So this would be the main line coming in, which contains the dial tone and it contains the DSL signal. And over here, so this would be an input, all right? The line. And over here, you can have that split. This, from here, you can use either the jack or the screw terminals, doesn't matter. And you can connect that as the main line to the rest of your house or the rest of the system that accommodates the building telephone service. And out of this one here, the voice or the dial tone is going to be filtered out, and the only DSL signal is going to go through that jack, and that is going to be connected to your modem, right? Modulation and demodulation device, modem. All right, so basically a modem is a box that takes the internet signal, which is in an analog form, transported over the wires into your house, and that analog signal is going to be demodulated into the digital signal that is going to service your internet connection, right? And then if you, through the internet in your house, you want to communicate with the outside world, use the internet, you're going to send a signal through the modem, and that box is going to modulate that into the analog signal and send it over the world. All right, so modulation, demodulation device, modulating, demodulating, modem. Okay, that's why it's called modem. Right? So that's the filtering here. Now I put like a little bit here. Dry loop is not to be confused with a hard loop. Okay, first of all, what's a dry loop? Okay, and please pay attention to that. A dry loop is a telephone line that contains only the internet signal, and you cannot use it as a phone anymore. The reason for that is that, well, obviously, a lot of people, pretty much all of us, have our cell phones. We are using our cell phones. So the need to purchase and pay additional money for something that's called the landline, which would be the regular POTS line, there's no need for that anymore. So people don't want to have another bill to pay just for something that they're going to use that they have anyways. Everybody has their own cell phone. So, but the wiring is still there, and it is still available to have just a DSL line to have a dry loop installed, right? And remember, dry loop is just a telephone line that doesn't have a telephone. It's dry, okay? But it only has the DSL, right? So dry loop is the one that connects the internet only, doesn't have the telephone anymore, right? I think I said it enough times, right? And that is not to be confused with a hard loop, because they're both loops, dry loop and hard loop. I kind of thought that I would give you that idea here. Now, what's a dry loop? We just talked about that. It's a POTS line with only DSL signal, a telephone line with no voice dial tone. Right? Used when subscriber wishes to purchase internet only, but no telephone service over a regular telephone line. And over here we have the phone jack that has just a DSL, which is a dry loop, then the POTS filter, and that POTS filter from the modem connection here. See that? A modem? Right. It goes into the DSL input of the modem. Right? Then over here you have the LAN ports, local area network ports, and you can connect that to whatever your device is, and it actually plugs into the wall to get some power. So dry loop is a telephone line that has no telephone signal on it, just the internet. Okay, we're going to study this a little bit further, but you might want to go back into your notes, I mean this point from the future lectures, and so you can get the idea of a hard loop. Hard loop has nothing to do with the telephone connection here. Right? Hard loop is a RJ45 jack Ethernet plug. Okay? It's an Ethernet plug. That's the plug that you use to connect your computer to the network. Okay? Now it's a direct feed from the transmit pair to receive pair. Okay, when you see Cat5e, category 5, category 5e, Cat5e, E stands for extended, and that's pretty much the lowest category cable that is pretty much used in the Ethernet industry right now at this point, 2021. Now, it has 4 pairs. You see, pair number 1, blue, pair number 2, orange, green, and brown. Right now, this you can tell that this is a B configuration, okay, because pair number 2 is green. A configuration would be blue, orange, green, brown, and a B configuration is blue, green, orange, brown. The oranges and greens are switched in Cat5e configuration. Right? Cat6, the blues and the browns are also switched. And we got a train count. We know that one now. Right? So now the blue pair is not being used in Cat5e. The green and the orange pairs are the crucial ones in the Cat5e Ethernet communication. One is transmit, one is receive pair. Now, which one is transmit, which one is receive? Obviously, that depends on which end of the cable you're looking at it, right? So one communicates the signal one way, the other one communicates the signal the other way. Right? So if you have a computer network card and it plugs into the Ethernet equipment such as switch, then the wiring is done in such a way that if you have a straight link, which we just made during the lab, the transmit pair from the computer is going to be connected to the receive pair on the whatever equipment, and the transmit pair on the whatever equipment is going to connect to the receive pair on the computer, and that's how the two-way, it's just like a two-way highway communication is going to happen, and you're going to have a connection to the network. Now, notice here, the transmit pair is directly connected to the receive pair. So the transmit is looped into the receive, and the receive is looped into the transmit. It's just a loop. That is, you can purchase that for not that much money, or you can make one up yourself. You're just going to make one Ethernet plug, cut the wires and join them, or you can just cut the wires and to a certain length and feed them into the jack and crimp it in this way. Right? It is used for diagnostic purposes. Sometimes you're going to be asked to, or you're going to perform some tests on some wiring or whatnot, and you're going to plug this into one end of the cable, and on the other side you're going to plug in whatever else equipment, testing or diagnostic equipment you're going to use. Or sometimes it's being used on through the outside companies, third companies. You might have to carry a hard loop with yourself, or if not, you should be able to make it pretty quickly. If there's a third diagnostic company wants you to plug it in to one of the outlets at the cash register, at the store, or at some point at the demarcation point, you will know what to do. Just get a hard loop, plug it in, and let them do their testing from outside, and they will tell you when to unplug it. Okay, so dry loop, hard loop. Right? Now, wiring configuration for the pods, because we're still talking about the pods, telephone lines. The old way used to be something that's called a daisy chaining. Right? You would have a bunch of outlets in-house. Usually that will be done in the residential setting. You would have the telephone company jack. So this is a line coming from outside. And you would connect that into the first outlet, and then you would parallel connect it to another one, and then you would parallel connect this to another one, and whatever else you would, how many jacks you would have. And that would be the way it would work in the old days. You're still going to see some of those installations in some of the older houses. Okay? Or you're going to see that type of installation in some of the cheaply built houses. I'm not going to point any fingers, but some companies would hire companies. It's rarely happening right now because it's happening less and less. But if somebody wants to do a cheap telephone installation, they would just do that daisy chain type of a thing. Please do not do that anymore when you're having a new installation, because you're going to run into all kinds of problems, and I'll tell you what kind of problems you can run. So this is just another visual representation of this here on the bottom. Here's the telephone pole, utility pole, goes to the demarcation point, and inside goes the first jack, and then parallel connected to another jack, and so on. That will be the daisy chained configuration. Now, what you want to do is you want to do the star configuration. Every telephone jack will have a separate wire running home to the central location. Okay. Now, if all of them need to be connected parallel, they can be connected at the central location. If some of the jacks need to be taken off that line and used maybe as an Ethernet jack instead of a telephone jack, now it can be done. Of course, for that, you should not use the Cat3 telephone wiring that is still available but should not be used anymore, because the telephone wire can run over the Ethernet cable, but not vice versa. Right? So all the telephone jack outlets should be run with the Cat5e minimum, or sometimes Cat6. We'll go over that, what the categories are as well. And they should home run to central location. This way, at the central location, you have a control of which outlet to use for which purpose and how to connect those. Okay. So that's the configuration that should be done right now. Right now, we're going to go on to something that's called a 25 pair color code. Right, 25 pair color code. It is important that some sort of a color coding is established, because when it comes to installing communications lines, you're not dealing usually with larger buildings. You're not dealing with one line or two lines, or 5 lines even. You're dealing sometimes with a couple hundred of lines, 500 lines maybe. Okay, so then if this is not organized in some certain way that can be ciphered and deciphered easily, then it would just be such a mess that you would install it once, and if you had to come back a week later, you will not know what is connected to what. So color code has been established. All right, now 25 pair color code. Usually you still are going to see the category 3 for telephone systems cables in in the 25 pair, but you also are going to see Cat 5 or Cat 5e. Sometimes I think actually I've seen Cat 6 cable that was 25 pair. All right, so can you see the differences? You can't see the differences on the screen maybe here because the zoom is watering down the resolution here. But you can see that the 25 pair cable Cat 3 has a little bit of twist, just a light twist, just to get rid of the crosstalk. We'll talk about that too. And Cat 5e, the twist is much harder, much more dense, okay, and much more consistent, and it also has a separator here, right? Okay, like a strength member. Right now, how does the 25 pair color code works? 25 pair. Let's get the multiplication cable. 5 times 5 equals 25. Got it? Got it. All right. So we have 5 groups: white group, red group, black group, yellow group, and violet group. Right? So each group contains 5 pairs. Remember the blue, orange, green, brown? Okay, look, blue, orange, green, brown. And slate. Slate stands for gray. I think the SLT slate was decided upon to choose that designation instead of gray because sometimes the documentation gets coffee stains or dust stains or whatever. So the green or gray, they kind of would look similar, right? So something has to be distinguished. I think that was the reason. So just have to remember that blue, orange, green, brown, slate, okay? Because that repeats for every group. Right? Now, if you look at the cables here, the pairs, you see that? Here's the white group because it has a white stripe and the designation colors. So here's a group color. So this group color will be white. This will be the first 4 colors of the white group: blue, orange, green, brown. There is no slate because this cable only has 4 pairs. All right. If it were a red group, it would be on a red background. So it would be red and blue, red and orange, red and green, red and brown, red and slate if it was 5 pair cable. Okay? So let's go back and look at this again. 5 groups: white, blue, orange, green, brown, slate. Okay? Red, blue, orange, green, brown, slate. Right? Then go to black, blue, orange, green, brown, slate. Yellow, same idea. Violet, same idea. 25 connections, 25 pairs, right? Because each pair has 2 conductors. Right? So now we have 5 groups. 1, 2, 3, 4, 5. And each group has 5 designations. 1, 2, 3, 4, and 5. So 5 times 5, that gives you 25 pairs. Right? Now, blue, orange, green, brown, slate, you don't even have to find a way of remembering that because that is just, if you keep using that, before you know it, that is going to become part of your DNA of knowing how to knowing how this works. So blue, orange, green, brown, slate. Okay, blue, orange, green, brown, slate, and so on. The group colors. I'll show you a very, very easy way to remember the group colors. Okay, so these are the group colors. These are the designation colors. All right, so group colors. Remember that we have used group color 1, which is white, because we already dealt with that. You should remember that by association. Just you have used that. White, blue, white, orange, white, green, white, brown. All right, now think of Canadian colors. All right, so we have the next one is red because we are in Canada. Now, if somebody was in Sweden, too bad. They still have to think Canadian colors. All right. But it's just easier for us to remember. Okay, because first one is white because we always used it already. Canadian colors red. Now think of that. Here is the black and yellow. There is, I always tell that rhyming story here. In the southern states in America, especially in Texas and surrounding states there, Arcona, Arkansas, there is that snake that's called coral snake, right? And it has black, yellow, and red rings. You can look at that. It's called coral snake. And there also is another one that is an imposter. Now, that coral snake is extremely poisonous snake. The point that is, in Texas, I drove through Texas a couple of times, and in the truck stops or anywhere in the parks, there are signs, don't walk on grass. Not because they want to keep the grass nice and clean, but there could be snakes hidden in the grass and they don't want you to get in trouble. That's why also they wear those cowboy boots, not to look cool, although they do look cool, but the snakes usually bite a certain height, and those cowboy boots prevent that, right? Thick leather, right? So there's another snake that also has the similar colored rings in a pattern along its length, but they're arranged in a certain in a little bit different way. Now, when the black ring meets the yellow ring, that is the poisonous snake. The other one is just pretending to be the other one, the poisonous, just to chase people away or anybody. So they have a rhyme in the kindergartens and elementary schools for the kids to avoid those type of snakes. And it says, black and yellow kill a fellow, right? So black and yellow kill a fellow. So white, Canadian colors red, black and yellow kill a fellow, and violet sounds almost like violence, and violence is the last thing that we need or want. So that is the last color, all right? So white, red, black, yellow, violet, okay? And each of them have the blue, orange, green, brown slate, blue, orange, green, brown slate, blue, orange, green, brown slate. So you know that pair number 7 of the 25 pair color code is going to be red, orange, right? Because 1, 2, 3, 4, 5, 6, 7 right here. All right. Pair number 11 is going to be black and blue, and so on. All right. That's an easy way to remember the color code. All right, 25 pair color code. Also, when you strip that cable, and we will play with that cable in, I think it's the next lab that we're going to have after this one. Oh, that train just doesn't stop. Okay, as if somebody didn't know that he's already here, okay? All right, if you strip the jacketing of that 25 pair color cable, you're going to see a ribbon also. Sometimes it's a ribbon and sometimes it's just a string. You're also going to find something that's called a ripcord. A ripcord is used to cut through the jacketing so you could strip to the length that you want the cable. All right. Now, if it's a ribbon or the marking string, it is going to be spirally wrapped, very gently spirally wrapped around the length of the cable. Okay. And if it's a ribbon, it's going to be the same thing, and then you're going to have a ripcord. Now, the ripcord is not spirally wrapped, it's just running straight along, so you could just make a nick and just pull that and just peel off the jacketing with a ripcord. Right? Now, A 25K pair cable just by itself is going to have the white ribbon. If it's because sometimes, remember I showed you the demarc point where there's 100 pair cable, there's no more colors. The colors are the same, but it's just 4 of those packed into one jacketing, and each of that 25 pair color cable is spirally wrapped with the color-coded ribbon or a string. So it'll be white, blue, orange, and brown string. This is just one by itself, which will be the first one. So of course it's going to have the white ribbon. Okay? Here's an example of a 100 pair cable. Sorry, I told you the wrong colors. The first would be white ribbon. Second one will be orange ribbon, green ribbon, and brown. Blue, orange, green, brown. I gave you the right one. Blue, orange, green, brown ribbon. Okay. There you go. Sometimes you're going to see that, or sometimes you're just going to have a string. Right? So now it is important when you strip the jacketing, you take those ribbons and you tie a knot around that bundle that corresponds with that ribbon, right at the point where you're stripped here, when the interface of the jacketing and where the stripped wires are. Because if you don't, they are just going to mix within each other, and you're not going to know whether that blue-orange pair is part of the first bundle or is the third bundle. And that way you can still trace them out, but it's going to take you way longer, right? So that's how 100 pair cable is made out of 25 bundles. Okay? All right, applications for that. Example 1, multi-pair links in telecommunications, usually for telephony. Here is the BIX terminal, and we'll have a long lecture on what BIX is. Actually, you're going to have to watch the video. That has to do with the lab, all right? So this is how those pairs are terminated on the BIX terminal. All right, here's the 25 pair cable. And pair number 1 goes into the first 2 terminals. Pair number 2 is going to the second pair, third pair, fourth pair, fifth pair. Here's the white group. Remember what comes after white? Canadian colors red. Okay, so it'll be red, blue, red, orange, red, green, red, brown, red, slate. 5 pairs. All right. And then remember, black and yellow kill a fellow. Black, yellow, violet. All right. So that's how they are terminated. Now the BIX is the BIX terminal. The connections, they connect straight through from the back to the front, just like that. They connect. So you can punch the pair here, and you can grab the pair from the front. So that's how those are arranged right here. Okay. Here are some 25 pair cables terminated at the back of those BICs, and from the front you can use something that's called a cross-connect cable, that you can just punch another, just a cross-connect cable, just a one pair, run it along the frame here, do a little bit service loop, and connect it anywhere you want to the field wiring. Pretty nifty system here, right? So the structure is from the one side is basically permanently terminated, so you can know which pair is which. The structure here is also permanently terminated at the back of the BIX terminal, and then you know what wire, because those are going to be labeled. And then if you want to connect line 1 to a specific telephone jack that is somewhere in the building and it's marked here, you're just going to connect it here, run the cross-connect cable right here, and connect it right into wherever it is. Very, very, very clever thing, okay? This will be called the termination, the field termination blocks, and this will be the field wiring cables, and these rings here are just wire management rings, okay? And this is a cross-connect cable, and the connection used is not a screw terminal. It is something that's called a insulation displacement connection, and we will talk about as well. And that uses the punch down tool that we already have used. Now, sometimes you use the 110 punch down tool, and 110 is just a name. Or sometimes you use the BIX punch down tool. On the BIX terminals, you use the BIX punch down tool because it's shaped to accommodate the shape of the terminal here. And if there is 110 terminal that we already have used, you should use the 110 punch down tool. Application example 2. Here is a telephone system. Okay. The telephone system is is accommodating. This is a conventional telephone system, which we'll talk about later. This is a little small one here, right? 3 by 8. Look at this. It doesn't even utilize the BIX terminals to accommodate the outside lines. 1, 2, 3 outside lines, and it's capable of 8 extensions. Usually it's used for a small business scenario. The next one would be 616, which would accommodate 6 internal outside lines and would terminate into 16 lines here. So you would have 25 pair cable connecting to this Amphenol connector. 25 pair connector, it just goes plugged in right here. And there's a 25 pair cable that basically breaks out into the BIX terminal. So you can cross-connect those pairs anywhere you want to any outlets that are corresponding to the field wiring. Okay, so here's a BIX termination strip, telephone KSU, key service unit. That's the telephone system, 25 pair cable, Amphenol or RJ register jack, 21X connector. Can you name other uses for multiple pair cables? I'm just going to leave you with that. All right. Now, I'm not going to start with another lesson here. This is where we're going to finish. Any questions about what we have talked about so far? Or we have done anything about the labs, anything about the quiz, anything about anything? We still have a couple minutes here. You can pipe in if you want on voice, or you can just type if you want. And I'm just going to wait a few more seconds. If not, going once, going twice, and...
One question. Is the quiz the same test, or is it a different test?
The quiz, same as test? No, this is a quiz, and we're going to also have a test. The difference between the test and the quiz, that quiz is just a kind of a teaser for the test, and the test is going to have more questions, and pretty much some of the questions that were on the quiz, they might not be repeated on the test. So even though the quiz is not worth that much over the whole thing, I would still encourage you to pay a good attention to writing the quiz, because some of the questions might be worth a little bit more later.
Okay.
All right. I hope I answered the question. If not,
and what is going to be the test? When is the test will be?
Oh, let's see here. Are we kind of getting late with the schedule here or not? Today is week 6. Let's just quickly go content. Yeah. Course outline. The test should be coming soon. Here is the, come on, work for me. Refresh. Oh, I did it too soon. All right, here's the course plan. I'm just going to zoom in a little bit. That's not the thing. Here's our course plan. Oh, where is the test 1? That's going to be week 6. So, well, I might deploy the test at the end of this week or in the beginning of next. So it's going to be the same format. It's going to be in the same way as quiz. Okay.
Okay. Thank you.
You're welcome. All right, cool. So now you still have a few minutes to make yourself a fresh coffee. I'm trying to be conscious of you having to go to the next class here. And I think this worked this time. And next time we will talk about the conventional phone systems, which are still being used, and then we're going to move on to something that's called VoIP telephone systems, and then we'll talk about different types of networks, and that's pretty much going to be it, if I'm not mistaken. Look at the course plan. We'll have to cover all those topics then. All right, cool. So that's it for today's class, and enjoy the rest of your day, and burn off all those extra calories that you got during the Thanksgiving weekend. Have a great one. Thank you, guys.